Thanks very much, George, and good afternoon, everyone. Thank you all for joining us for the April 2017 edition of the Sustainable Materials Management Web Academy. We're happy to have you participating. It looks like we already have a lot of people online and more are trickling in. So as George said, I am Brandon Bray with EPA's Office of Resource Conservation and Recovery, where I work on our Sustainable Electronics team. I'm excited to have everyone here for today's 90-minute webinar. EPA is hosting this webinar, and it will provide all of you with an opportunity to hear about some cutting-edge research into the materials composition of consumer electronics. The Rochester Institute of Technology, in collaboration with the Staples Sustainable Innovation Lab and the Consumer Technology Association, has conducted a comprehensive analysis to determine the material footprint of consumer technology being used in U.S. households from 1990 to 2015. This analysis looked at products, their weights, and key materials that are being consumed in manufacturing them. Today, we'll be hearing about the conclusions so far of this research, as well as some plans for the next steps for this work. I'd like to welcome today's speakers. We have three of them: Mark Buckley with Staples Inc., Walter Elkhorn with the Consumer Technology Association, and Callie Babbitt from the Golisano Institute for Sustainability at the Rochester Institute of Technology. We're planning on taking one or two burning questions following each of the first two sections of the presentation, assuming that we stay on time, and we will have a longer question and answer session at the conclusion of the third section of the presentation. Please feel free to type any questions you have throughout the webinar into the little questions application that should be on the side of your screen from GoToWebinar. Moving into today's webinar, please also note the disclaimer that should be up on your screens right now. And now with that, I will introduce our first speaker. So I have the great pleasure of introducing Mark Buckley, who is Vice President of Environmental Affairs at Staples. Mark directs Staples' global environmental and sustainable business practices, and he is responsible for driving the company's sustainability efforts in a number of areas, including the development of more sustainable products, packaging, and services, customer recycling solutions, internal waste reduction, the development of global carbon reduction and renewable energy strategies, as well as environmental education for customers and associates focused on sustainable business solutions. Mark has been with Staples for 27 years. He has been in his current role for 15 years and previously was Vice President of Facilities Management and Purchasing for Staples, where he directed their company-wide recycling and energy conservation programs. Mark holds a bachelor's degree in biology from St. Anselm's College and is an active member of a number of environmental and nonprofit organizations, including the Boreal Business Forum, the Forest Legality Alliance, the Carbon Canopy. He's on the Advisory Council for the Product Stewardship Institute, the Advisory Board for the Bellantera Foundation. He's on the board of Earth Force, a U.S.-based environmental education organization, and Mark is a board member of the John Andrew Mazey Foundation. I would also like to note that Mark leads Staples' efforts in EPA's Sustainable Materials Management Electronics Challenge. Staples was a founding member of the Electronics Challenge, has won our Gold Tier Award for the last 3 years, and most recently in January 2017 was also awarded our Champion Award in the non-product category for their public outreach efforts and general robust recycling program. So with that, I will turn it over to Mark. Thank you, Mark.
Thank you, Brandon, and good afternoon, everyone. If you advance to the first slide, please. I'm really delighted to be on the call today and want to provide a bit of context for how Staples looks at sustainable materials management. Again, I think Staples is in sort of a unique position, given the position that we have in the marketplace, to provide interesting sets of solutions, but also hopefully an interesting perspective to folks, on the call today. Obviously, this is Staples' perspective, and there are many companies out there that are doing wonderful work in the area of sustainable materials management. For those of you who don't know Staples, we're a $21 billion reseller of diverse sets of products and services that businesses need to succeed, ranging from office products to facilities management solutions and a full range of other services. For those of you who are not familiar, we're broken out into 3 separate business units. We have a retail business unit, which most of you are probably quite familiar with. We have our .com, our e-commerce business, and we have our business-to-business business, which is called Staples Advantage, and it services the needs of businesses as small as an individual entrepreneur all the way up to a multinational Fortune 500 company and everyone in between. We also have our own robust private label brand line of products, and over 27% of our current sales come from those products. So we have a unique opportunity to really influence design, specification, and bringing some of those more sustainable products to market. Longer term, our aspiration is to become our customers' trusted sustainable business solutions provider and partner, and provide unique solutions that customers are not able to find anywhere else. Next slide, please. So, like many organizations, we focus first and foremost on what can we do to use our position in the marketplace to recover more material from our customers and to responsibly recycle it. So again, as a company that aspires to be a sustainable business solutions provider to customers, we have to think about the life cycle relationship of products as they're being acquired by the customer, as they're being used, as that asset is being used in the customer's environment. And then what can we do at end of life to think about what our responsibility can and should be at end of life for those products to responsibly recover and redeploy those assets in a way that keeps them out of landfills and obviously reduces the environmental impact associated with improper disposal. So again, what we did is we started our journey, I guess, probably in 2003, and EPA was really a critical partner in actually getting us up and running, offering these unique solutions to customers. In 2003, we were one of the early signatories on the plug-into e-cycling program through the EPA, and conducted a number of pilots that actually informed us and allowed us to put together an everyday recycling program for technology, consumer electronics, in our stores, and that program was started in 2007. So we're proud to say we were the first national retailer to offer an everyday responsible recycling solution for customers across the United States. And so today, Staples will accept up to 7 pieces of technology at any Staples store for no charge, and the technology is recycled using the Stewart certified and R2 certified partner, Electronics Recyclers International.
Mark,
Today,
this is Brandon.
Yeah,
I'm going to just interrupt for a second. We're getting a lot of audio feedback, so everyone can just make sure they're on mute, and Mark, if it's on your end, just close your door. Hey.
That's okay. Is this better? Okay. So today, Staples across all of our lines of business offer a wide range of recycling solutions for products and materials as diverse as cubicle systems, technology, ink and toner recycling, batteries, ballasts, lamps, and even hard to recycle items like personal protective gear, coffee pods, and writing instruments, etc. Next slide, please. So, as we've moved along our journey of sustainable materials management, we understand that recovery and recycling and diversion is not enough. So really we're thinking about our position in the value chain and the supply chain a bit differently. So we're committed to increasing and incorporating the amount of sustainable materials for products that can be directly used into new products within our direct supply chain. We have a whole line of remanufactured cubicle systems that meet a BIFNA level standard today, where they're totally re-indexed and remanufactured. We cut about 110 manufacturing steps out of the process, so the embedded energy The material use, the toxic burden on the system is greatly reduced. Since 2007, we've recycled over 500 million ink and toner cartridges, many of them going back into remanufactured ink and toner cartridges under our Sustainable Earth brand. And today, for the material that can't be reused as a direct remanufacturing cartridges, those resins are reground, and we actually use those materials for products such as our Sustainable Earth calculators and staplers that are made out of 100% regrind. So as you can see, what we've tried to do is within our ecosystem, we've tried to create closed loop systems where we directly control materials and put those materials back into service, thinking more broadly about this emerging circular economy. In addition to that, we've increased the amount of post-consumer recycled content papers and agricultural waste fibers into all paper grades across our portfolio of copy paper and other paper offerings for our customers. Next slide, please. So we're really proud and excited to be part of this really groundbreaking research that's been done at RIT in conjunction with the Consumer Technology Association and EPA. As was mentioned before, Staples has a Sustainable Innovation Lab at the Golisano Institute of Sustainability, looking at some of these emerging challenges and opportunities as they relate to circular economy. So again, sustainable material and product design really requires life cycle thinking, and while to date most of that thinking has really revolved around our direct control over these material flows, we need to think more broadly and think beyond the confines of our direct impacts, and think about where our sphere of influence could actually be more effective in other areas. So we're excited about that. We look at this foundational research and the development of what will be required to really start to utilize more of these sustainable materials to build a framework for this new circular economy. While this research is really looking at,
Mark, I'm sorry, this is Brandon again. I'm sorry to interrupt. We're getting a lot of bad feedback, and you're very muffled, and a lot of viewers are having some trouble hearing you. I don't know if you're on speakerphone, if you can go off speakerphone, or if you possibly are dialed in on both your computer and your phone. Just turn off the sound on one of those.
Okay, just on only on my phone right now, and I've not been on speaker, so I
just got a lot
better. Okay, I turned off the computer. Sorry about that. So I guess in conclusion, we're excited to be part of this sort of this groundbreaking research, which again looks sort of in the rearview mirror a bit on the history of products in the consumer ecosystem. We think it can be really has a lot of potential for us to start to think more predictively about where these materials start to enter into supply chains, how they're being used by consumers, and then how Staples and others can effectively start to use their position in the marketplace to recover those materials and put them back into service as part of a more circular line of thinking. So again, my apologies for the audio problems, and I'm happy to take any questions that folks might have.
Thanks so much, Mark, and whatever you just did there worked great.
Okay.
You were coming across much clearer. We've been getting a lot of questions about Staples' in-store collection program, and what sort of support Staples is providing for electronics recycling, where people can access a list of the items that Staples takes, where viewers can find that information, in particular about batteries, and we've gotten a couple of questions about coffee pods, and kind of where collection is located in stores and how that works. Would you be able to walk through that quickly for people?
Sure. Quickly, the coffee pod programs, the battery programs, with the exception of rechargeable batteries, lamp recycling, ballast recycling, all of those services are available through our .com business, so online. and also through our Staples Advantage group, not available in stores. What isn't available in stores today is recycling for ink and toner cartridges, for rechargeable batteries, and for up to 7 pieces of electronics that customers want to recycle at the store. The only exception being we don't take TVs. At this point, we don't sell them, and again, just more out of safety concerns for some of the store associates than anything else. But anything else that you would find in a traditional office and consumer electronics that you find at home, including gaming devices, etc., those all can come back to Staples 7 days a week, up to 7 pieces per day per customer.
Thanks, Mark. And could you take a couple of minutes to talk a bit about the implementation of this model at Staples and what you would consider to be some of the biggest influences for getting suppliers on board with this program?
Yeah, sure. Great question, Brandon. I think that initially I really can't say enough about the importance of the EPA partnership early on as part of the plug-in to e-cycling program. We ran a number of pilots in different parts of the country that gave us confidence that we could actually put a program like this together, and certainly we've expanded this program as a paid service on our business-to-business platform. So it's been really, it's been a journey for us, and again, it's been very important that EPA be a part of that process. It's also very important, and has been very important, to have the right recycling partner, and we've been very fortunate that Electronics Recyclers International, ERI, has been a tremendous partner. They're both R2 and E-Stewart certified. They're ISO certified, and their portfolio of decommissioning facilities and recycling facilities matched up very nicely geographically with our footprint. So that's been our experience. Obviously, it's different for different companies, but that's been our experience, and certainly made all the difference in the world in us being able to deliver this kind of a program to our retail customers.
Thanks very much, Mark, and thank you to everyone on the line for all of the great questions so far. There are a lot more than I was just able to ask Mark. Hopefully we'll have time to get to more of them at the end. Please continue submitting your questions, and like I said, we'll get to as many as possible at the end of the webinar. Our next speaker, Walter Elkhorn, is Vice President for Environmental Affairs and Industry Sustainability at the Consumer Technology Association. Walter manages legislative initiatives impacting electronic product recycling, design, eco-labeling, packaging, and hazardous materials restrictions for the Consumer Technology Association, or CTA. Walter currently coordinates CTA's e-cycling leadership initiative and serves as an advocate for the industry on Capitol Hill, before regulatory agencies, and before state legislatures on a range of sustainability and related issues. So with that, I will turn it over to Walter. Thanks, Walter.
All right, thank you very much, Brandon. Appreciate the opportunity to be here today. Let's see, so oh, there we go. Next slide, please. All right, great. So just a little bit of background on Consumer Technology Association. I think many of you are already aware of us, but we're a trade association. We represent companies in the consumer electronics and the broader consumer technology industry. We're probably, on materials issues, we're probably best known for our manufacturer members, but we do have others in our membership. As a matter of fact, most of our majority of our members are small businesses or startups. What we're probably best known for is being the owner and producer of CES. In fact, the study that Callie's going to summarize was the preliminary results were announced at this past CES. But CES is obviously a big activity, and it's something that gives us a kind of a bird's eye view on new technologies and new developments in the consumer technology industry. And we are an industry where innovation is the king. These are very competitive markets, and things change, technologies change, products change very quickly. And that's something we're we're used to and comfortable with. Go to the next slide, please. So this slide gives everyone, I think, a pretty familiar example of technology change in our industry. For video displays are probably, well, they definitely are, at least by weight, the largest product in the consumer technology industry and has been for a number of years. And as you can see, I think many of us, at least, who have been around a few years, remember the old days of CRTs when that was it. Cathode ray tubes were the way that you would watch television or use your computer, would be looking at a cathode ray tube video monitor. That did begin to change. That technology had been in use for a long time, but we then moved away from that, and consumers started buying better products. Plasma was an early alternative to CRT technology, and then into the LCDs, which came in, and there was some overlap here with these different product types. And today we're seeing the vast majority of displays use LED LCD technology. So what we've seen is a change in the underlying materials that are used, and I think, as many of you or most of you are going to be aware, we have leaded glass and CRTs, plasma. We had materials of concern with LCDs, still required mercury, and now with LEDs, those materials of concern are no longer in them. So this gives you one insight into, at least for the video display technologies, how those have changed over the years. Go ahead, the next slide. So this is something that I think I was maybe a little brainwashed with this idea about 25 years ago, but the EPA waste management hierarchy is certainly something that a lot of us have grown up with and has influenced our thinking. Certainly for this study, it is something that we have very much taken into consideration. We do have, as the waste management hierarchy provides that hierarchy of the top being source reduction reuse. Recycling's up there, but it's not the very top, but it's close. Then energy recovery and treatment and disposal being the least preferred. We have just in the last 2 or 3 years seen consumer electronics become a declining portion of the municipal waste stream for a number of years, and this also shows up in the RIT study results. We were a fast increasing portion of the municipal solid waste stream, but that has finally flipped. And the reason for this is primarily because of changes in the technology and source reduction in terms of different types of materials and different amounts of materials that are used in products. And just a little commercial here for on government policy. That's we think government policy, when possible, should encourage source reduction and be mindful of that for materials policies at all levels. Okay, go ahead. The next slide, please. So just a quick overview of some of the history of materials in our industry. This was the focus of the RIT study for phase 1. And we have had some issues in our industry on materials management over the years. I like to call ourselves the guinea pig, or at least the big guinea pig, for state-level extended producer responsibility laws. We weren't the first in the U.S. Rechargeable batteries were probably the first thermostats, and then since we've jumped in, we do see other products like paint and mattresses step in. So we are definitely, though, in the middle of the experimental phase in terms of how this works with the current financing in most states is a cost internalization financing. So it is certainly puts us in a guinea pig situation. Because of the cost internalization, where our manufacturers are spending, by our estimates, about $125 million a year on recycling. That's enough to get industry's attention, and frankly, it is probably enough that it makes it unlikely that this type of cost internalization policy will be at least advocated by other industries going into the future. But it also has resulted in our interest in looking at some of the other materials issues as CTA support for this study, I think is one example. Apart from the policy and the legal issues, it's important to note that the reuse markets have really taken off for things like smartphones and tablets. This has happened without any sort of government initiative or policy initiative. It's really just been the market has taken hold where now retailers, carriers in particular, have helped collect and put product mobile devices that otherwise might not have been used again back into circulation. So this is something that sometimes when we talk a lot about the laws and the mandated programs, we forget that there's this whole nother system that's emerged outside of that for the reuse and refurbishment of mobile devices. And what this has all meant is that we have seen a significant decline in the amount of consumer electronics that have been landfilled that go to disposal, and that's a good thing. I think everybody is happy about that. So what we haven't really seen is as much discussion, as much visibility in the materials that are used in our products. That's again something Callie will be talking a little bit about as our products have changed. And just one final note on what's driving those changes. There really are a number of economic and technological forces. Clearly, when new technologies become available, produce better products, that drives change in our industry, and many times innovative ways to use technologies is also a common way that companies have succeeded. We really want to, with this study and other things that we're doing at CTA, raise more visibility of these materials issues across, not just externally with folks on this webinar, but also internally in the industry. A lot of times, just having visibility on these material issues can make a difference in terms of decisions to use different technologies or to how to build those technologies out. So this process we think is a healthy one and something we encourage. More changes coming. There's no doubt. We're going to see new products. We're going to see new devices, new uses of technology in the consumer space, and we also see with that a long-term trend towards dematerialization, if you will. It's a term some people use, but this really parallels changes in the economy where we are seeing more value placed on services, on intellectual property, on software, and away from the pure materials or just the basic materials that are used that go into these products. That's becoming less and less of an economic driver, whereas the IP and the services are becoming much more important. So that's it for me. And Brandon, thank you for the opportunity. Be happy to answer any questions anyone has.
Yeah, thanks very much, Walter. And yeah, we are continuing to get a lot of great questions in. Some of you, I will just say, are getting a little ahead of yourselves, and hopefully your questions will be answered by Callie's presentation. And if they aren't, feel free to bring them to our attention again if your questions haven't been answered after Callie gets a chance to speak. So Walter, we got a few questions about how you feel about the waste management hierarchy and how it relates to design for the environment. So obviously the design of electronic devices influences the materials that you're sourcing for those devices, how reusable they are, how recyclable they are, and so on. Do you think that a greater emphasis should be being placed on design for the environment?
I think it is already. I think we're seeing the results of that, but not through government regulation. You know, I think there's an old idea that if you make manufacturers take back their products, they'll design them better for recycling in the future. That's proven, at least in this country, not to be the case for a variety of reasons. But what you have seen is technology and economic forces driving the waste management hierarchy, driving fewer materials into products, driving more efficiency into the designs, which results in fewer materials rather being needed. So I think that's something that we're very interested in probing further. It's almost like a situation where you know, it's not like you have folks that are committed to implementing the waste management hierarchy, making these things happen. These are results that are happening as a byproduct of technological and economic changes. And I think one of the keys to all this is figuring out how that can be encouraged and, you know, that can be leveraged in a positive direction without kind of having the waste management hierarchy take over.
Thanks, Walter. We've also gotten a couple of questions on what CTA and the electronics industry in general is doing to push recycling throughout the industry. Obviously, better design and technological changes are going a long way towards reducing the volume of electronics being disposed of, but there are still lots of legacy equipment out there that needs to be collected and taken care of. You, of course, refer to everyone's favorite topic, CRTs. Can you talk a bit about what CTA is doing to push the industry to be collecting legacy equipment, especially in areas where the collection infrastructure, like rural areas, might not be that well developed?
Yeah, and I happy to. We kicked off back in 2011 something called the E-Cycling Leadership Initiative, and we did that as a way to coordinate manufacturer and retailer efforts to recycle, to collect and recycle old devices, and through that process, and I think we're about to release our 6th annual report. But through that process, we have arranged for the recycling of approximately 4 billion pounds of electronics. And one of my slides, I mentioned that we're spending about $125 million a year. That's without any recovery of funding to do this. I think we've done a pretty amazing job so far of collecting legacy equipment that is out in the marketplace, basically distributed into everyone's homes, and then has to be recollected, reaggregated in order for it to be recycled. I wouldn't say we're perfect, but as far as I can tell, no other industry has done as much as we have done to recycle products that are widely distributed in the home and spent as much money as we have spent on this. That's kind of part of the guinea pig thing. So I think we can probably always do better, but I'm proud of the amount that our industry's done so far to recycle.
Thanks so much, Walter. So again, we just want to put a couple of burning questions that we've been getting kind of repeats of right there, but we will try and address as many questions as we can after Callie's presentation, and please keep sending us all of your questions. And with that, we'll get to our final speaker, Callie Babbitt. Callie is an associate professor at the Golisano Institute for Sustainability at Rochester Institute of Technology, where she conducts research to proactively quantify and minimize environmental impacts of emerging technologies. Callie's research group creates new methods and models in the field of industrial ecology that are inspired by the study of ecological systems in nature. They apply these models to study sustainability challenges and solutions for everything from food waste management to consumer electronics, lithium-ion batteries, electric vehicles, and nanomaterials. Callie also collaborates widely on sustainability research related to the food, energy, water nexus, critical minerals, biofuels, waste management systems, and renewable energy technologies. She translates this research into courses at RIT in sustainability, architecture, and industrial design, and also into informal education programs at the K-12 level. Callie's collaboration with Rochester area schools and Women in Engineering at RIT aims to increase the number of female students who pursue science, engineering, and sustainability degrees and careers. These efforts have been recognized by national and international academic and research communities. In 2013, Callie was awarded the Faculty Early Career Development Program Award by the National Science Foundation. And in 2011, she received the AT&T Technology and Environment Award for her research and teaching efforts in sustainability. We're excited to have you here today, Callie, and I will turn it over to you to tell us some more about this research. Thanks.
Thank you very much, and thank you for having me on the call today to share some of our findings. Some of you may not have heard of the Golisano Institute for Sustainability, or RIT, before, so I'll just put a quick plug in for our organization. We are a PhD Masters and Masters of Architecture granting degree program in the beautiful city of Rochester, where today it's a balmy 70 degrees. It's like this year-round, I promise. And a lot of what we do in this institute is thinking about the systems level impacts of emerging technologies, and then how can we create cost-effective and industry-oriented solutions to translate this research into practice. And much of this research has to do with life cycle assessment, sustainable design, and things that are of critical interest to the electronics community. And a lot of my work has focused on the life cycle assessment of electronics simply because it's a really interesting system to study. It's a very complex system, and a lot of effort has been done in this space to create solutions. And I'm assuming that many folks on the call today have been part of this wide body of effort to create solutions for greener electronics. I myself have done a lot of work using life cycle assessment to identify environmental hotspots in computer technology and other electronics. And one of the things I started thinking a lot about was that as we apply these technologies, we're often able to see some incremental gains at a product level. We can think about redesigning an electronic, we can think about a single solution, but where we may run into challenge, or there may be some new and interesting questions to ask, are when we start to think about how these solutions interact and intersect between patterns of consumption. As you all know, consumers do not own just a single laptop. They own an entire suite of these interacting and interconnected products. And so we started to ask ourselves, you know, when we look at these products holistically and their ownership in this entire system, are the impacts going up, going down, staying the same, and what should we focus on to get the most impact, the most reduction and improvement when you look at the products as this system? And Brandon alluded to this in the introduction, but we started asking ourselves, you know, if we want to think about complex systems, where better than to turn than to nature itself? And so we asked ourselves if there was a parallel we could study in nature. And in fact, you know, the way that electronics are owned and operated and the interactions therein really reminded us of the kinds of interactions that you see in a natural ecosystem like the one on the screen here, where you have different organisms interacting. These interactions are often driven by exogenous forces, and as a result, you have certain material and nutrient and waste flows coming through the system. So we very literally applied this concept to consumer technology products and said, in the average American household, you have a wide array of complex products interacting. This interaction is governed by exogenous forces like the prices going down over time, potentially leading to an increase in consumption, as well as regulations, technology, and other things that Mark and Walter have mentioned. And as a result, this community of products, or this ecosystem, changes over time, and the resultant material, energy, and waste flows also change. And so this was really the concept underlying our research that sort of seeded this collaboration with CTA and Staples. And so what we wanted to do in this space is to try to create a sustainable materials management model that could apply rigorous scientific methodology to quantify the net material footprint of the consumer technology ecosystem. And specifically, we're thinking here about materials at this point, although there's a lot of discussion about how we will build and broaden this model over time to include more life cycle metrics. So we're specifically thinking about what resources are consumed as these consumers purchase products, what products are being held in the household and the materials in that stock, and then the ultimate flow of these products out of the household, whether it be to reuse or to e-scrap management. What we're reporting on today is really the results of the phase 1 of this effort, which was focused on collecting a wide array of data to establish a baseline, looking backwards over the last 25 years and asking what products have been owned and what has been their material footprint. Then we want to use that to understand what are some of these key material trends over time. Many of them are very intuitive and are known by a lot of stakeholders in the system, but we felt it was very important to apply this data-driven approach so that we could have a robust method that we could then use and adapt and apply over time to get ahead of the curve, so to speak. So how can we then apply the model for more proactive analysis, looking at the products that are coming out at next year's CES and other considerations about how consumers will be interacting with these products in the future. And that's really the subject of the phase 2 of this effort, which I won't be talking about today in much detail, but hopefully it gives you a sense of where this overall effort is going. So I'm going to spend a little bit of time talking about the approach and then highlighting some of the key findings. So the approach had 4 main parts to it in order to build up this model that then we can use very flexibly to analyze material footprints. Our first part of this approach was to think about what, in fact, is this technology product ecosystem. And in the next series of slides that I'll be showing, I'm using a convention where information in dotted lines represents inputs, data, assumptions, parameters that we specified. And in a solid black line, the outputs are the results from this finding. So the first step was really to characterize this product ecosystem. And we took as our focus the average, so to speak, U.S. household, and we looked at the 21 most common products that were owned from 1990 to 2015. The selection of products was informed by industry information and CTA and Staples inputs in helping us understand what representative products look like. And we constructed this ecosystem by understanding from the data that CTA collects what is the product adoption and ownership rate over time. For example, in 1990, we may have 2 CRTs per household, and in 2000 we may have 2.5 CRTs per household. Flash forward to 2015, we have about a half of the CRT per household. So you can see these represent an average. Not all households own these products. Some own more than one. So it comes out at the end to be this average ownership of all households in the U.S. The next step was to think about what is then coming into the house. What is being added to the ecosystem every year? And here we're quantifying that by looking at unit sales and shipments provided by data from CTA and IDC and other sources that we were able to access to characterize this information. So these are new products that are being purchased. We then used both of these 2 data inputs to understand how the given stock and at any given time changed over time, and then resultingly the product outflows. Now this is the one and only equation on the slide, just to give you an overview of how these are calculated. We basically thought about this as a material balance or mass balance. In other words, if a product accumulated in a household from one year to the next, in other words, the stock increased, then we would understand that to be driven by 2 factors: the number of products purchased or coming into the system, and then the number of products that were discarded or leaving the system. Outflows, as we have defined it here, is not distinguishing between whether or not the products are working, whether or not the products are being put into reuse or e-scrap streams, rather than they are just simply leaving the household. Hopefully we can refine this again in the future. Similarly, when we're thinking about the stock, this includes both working products as well as that CRT that I will suspect that many of you still have in your basement. So they may be non-working products or products that are no longer used but are still stored in the household. And then came the fun part, which was to think about how to translate unit sales, stock, and outflows into material and mass flows. And a lot of this data were collected by our own, or shall I say, my grad students' own hard work, disassembling and characterizing the material of a wide array of products, many representative samples of these 21 products, or most of them, and then multiple ones spanning this year, this time period. So we probably took apart between 100 and 150 products. We also supplemented this from data from the academic literature, from publicly available sources, other documentation, for example, data graciously provided by NCER. And certainly we are continuing to stockpile this data because despite our best efforts, there will always be questions about uncertainty and whether, say, the bill of materials that we're able to generate for a given smartphone, or in this picture, camera, is representative. So we're going to continue that effort over time and obviously want to partner because there's many others who are doing similar work, and we're always seeking to collect this kind of information for anyone who would like to collaborate. And finally, once we have this information about the average product mass, which may change over time, as well as an average product bill of materials and components, we then translated this into these cumulative flows. Again, the inflow, stock, and outflow. And so at this point, I'm going to transition into talking about some of the key findings. Now, obviously, this is just a very high-level overview for this time period, and much of this information and the data and models will be added to a report that's currently under editing and finalization for dissemination via CTA. So the first key finding from this study is that while product consumption has been growing over much of this time period, we've begun to see a slowing of the net material footprint. And again, this is, as Walter mentioned, largely due to consumer preferences, change in purchasing, which is thereby enabled by technological progress and substitution, i.e. flat panel display substituting for CRT TVs. And so in this slide, we're looking at a picture of the sales and shipments of new technologies into U.S. households annually from 1990 to 2015. I recognize that there's a lot to take in there, but some of the key things that I'll mention is that you can see that much of the ownership and much of this volume by unit is driven by mobile devices. And you can see this recent shift in device convergence where small single function products are being overtaken and converged with smartphones and other products. So again, this is unit sales, and obviously many of these products that represent a large contribution by unit are very, very small in mass. And so then we wanted to translate this into the material footprint or the mass footprint. And that's the subject of the chart I'm showing here, which is in the net weight of products consumed in metric tons. Now there's a few interesting things going on here. First, it was very surprising to us that we didn't see a nice smooth trend here, and we spent a lot of time trying to understand what was happening with this peak around 2005. And a lot of the colors that you hopefully are seeing there in red are the display technologies. And this is when we started to see the transition from CRT to flat panel display. And interestingly, the reason for this little dip is because during that time, the CRT sales were declining, and certainly flat panel display was increasing, but there's also a difference in mass between the two products. Also around this time, flat panels were relatively smaller than we see them now, and so their mass was smaller than they eventually grew to be or peaked maybe 5 years later. So during this period, you were replacing a larger, heavier product with a smaller, lightweight product, and the sales hadn't quite caught up with it yet. You can see that the curve kind of fleshed out a little bit later. And a lot of the conventional products like computers in green and the monitor and the display technology in brown and red really dominate this material footprint. When we really wanted to then dive into the materials, the second key finding we observed was that the material profile is relatively consistent. And we tried to look at this even more in depth with specific classes of products, looking at a class of products as it changed over time, and have gotten similar findings. And that there's more variability we have observed in products that are introduced in a given year, variability from make and model and design and material selection, than there actually is in year-over-year trends. So the material profile is relatively consistent. So this chart is the same sort of volume or scale as the one I showed previously, but now we're looking at breakdowns of material rather than breakdowns by product. And again, the graph is in metric tons of materials coming into the U.S. household over this 25-year period. And you can certainly see that it's largely dominated by bulk materials like plastics, a little bit of aluminum and other metals like magnesium creeping in there, ferrous metal, and certainly dominated by the CRT glass and lead coming out or coming into the household by way of those CRT televisions. Although in recent years you can see the display technology creeping back up. We also were interested in looking at things like batteries and printed circuit board or PCB material because that's certainly where the value is being driven in terms of recycling, as well as where we might be thinking about some of critical or emerging materials of interest. So we did a little bit of diving into some of these components and disaggregating the data. And I'll show that in a moment. In this chart, we're looking at the material flow entering the waste stream. And so you can see that this material flow certainly rose very quickly through the 2000s. It has peaked and maybe seeing some decline. I will note that, this is a very high-level, aggregated snapshot of the material flow. And so we want to interpret specific trends, but the exact number from one year to the next, we have a little bit less certainty in, and we are doing some subsequent uncertainty analysis. But here you can see again that this waste stream largely dominated by these bulk materials, and finally we're seeing, and as many of those of you in the recycling business have seen, declining amounts of these CRT televisions. However, they are still in households, and still that's beginning to phase out over time. And then we wanted to look at some of the specific materials. So we have a couple examples here, and the technical report we're preparing has more. Here we're looking at lead, and then the next graph looks at mercury. And this is the inflow, outflow, and then the larger line is the stock of lead. This is in metric tons. 98% of this is from CRTs. A much smaller percentage of this is from solder and other sources of lead. And certainly you can see a peak here that changes with the rise and fall of CRT televisions. And positive note being that we're beginning to see less and less coming out and to be managed in the waste stream. And then looking at mercury, it's interesting, you see a very similar peak, but shifted a few years later. We're thinking about here CCFL lighting in LCD displays. And as that has now become being phased out due to the increased purchase of LED technology, that's declining as well. So obviously this number is at a much smaller scale than that of lead, but it's an interesting trend and positive news for the industry. Where we also found a few opportunities where it's wise for us to think about some future study and look for opportunities for new innovations. Ideally, some of the findings from the study can be used to inform materials that we can prioritize for closing the loop for circular economy, and also thinking proactively about the need for developing recycling technologies and take-back or reuse technologies for other components in this material stream. Certainly the flat panel technology is one that's very interesting to us, and this is in net consumption of flat panel displays by metric tons, and then the colors correspond to where those display materials are found. And this is very interesting from the perspective of material supply chain and thinking about increased consumption of critical materials like indium, as well as rare earth elements that might be used in phosphors and other lighting for these technologies. So this is one we plan to track further as we go out in phase 2. And one that dovetails really nicely with a lot of the other research we're doing here at RIT is thinking about the lithium-ion battery waste stream. Currently, of course, this waste stream dominated by electronics, but certainly in the near future we'll see also electric vehicle batteries and other types of battery waste stream. And there's a clear increase over the last 5 years in these batteries entering the waste stream and requiring management. And this is, of course, very important to think about because of materials like lithium, which gets talked about a lot, although its supply chain perhaps may be a little bit more robust. But then other emerging materials like cobalt, which is much more of a concern from a sustainability perspective, as well as graphite and other materials that we might want to think about. Where are they coming from, and then how are we going to recycle them? So that's kind of the high-level findings of what we've done in this phase 1 project. And at this point, I'll just sort of wrap it up and talk a little bit about where this is all going. So the goal of the phase 1 was to establish this baseline material footprint. And currently we're editing the report that summarizes at a very high level some of these findings, as well as more detail on the data sources and the methodology used. And that will be disseminated via CTA and RIT. And then going forward, we will continue to be working on this model. We're adding some uncertainty analysis because these are right now just point estimates that I've shown that reflect trends over time, and we want to go back in and do sensitivity and see if we can look at any uncertainties that might exist in our data sources. Ultimately, all of that extended work will then be published in an academic research article. And then looking forward, you know, I think for many, some of these findings may reiterate what you sense or see in your work. But what we're really looking forward to is thinking about how to get ahead of this curve, how to do more proactive analysis. And so the phase of work we're currently initiated is to now expand this sustainable materials management model to look forward. So we're developing the model currently, and we plan to validate it using some key case studies of emerging technologies. And many of these aren't being sold yet, and so instead of relying on data from historic sales, we'll be using more of a scenario analysis approach about future growth and adoption scenarios, what best and worst case scenarios might be. We also plan to add some environmental metrics to this. For example, we can understand that these material flows have a given mass, but what is their implication in terms of their embodied energy or their value at end of life? And so there'll be some additional metrics added. And ultimately, this will be disseminated in down the line in more freely available tools implemented in Excel and MATLAB environments. And what we're thinking about right now, and certainly this is one area where we welcome collaboration and input, is what case studies to consider. And right now we're thinking about 3 key categories. Certainly there will continue to be products, like the traditional ones we've currently analyzed, as well as new ones, that are clearly in and of themselves consumer technologies. A few examples here on the screen, like the Echo, drone technology or UAV, and VR headset. So these are ones where you might say this is in and of itself a consumer technology, and we want to understand whether their adoption at, say, a maximum level may at one point cause material concerns or new opportunities. The second category that we're thinking about are products that have always used electricity but now have augmented materials that are making them smart. For example, smart lighting, thermostats, security systems. So we're adding more electronic components to traditional products with a plug, but what does that actually entail from a sustainability perspective? It also gives us an opportunity to think about the sustainability benefit. For example, reduced energy use. And finally, thinking about what are the impacts of products that have had no historic technology function but are now being augmented with electronics for smart functionality. And things like smart sneakers, for example, imply an entirely new set of materials. And whether this is now handled as e-scrap, and we're thinking about how to deal with textiles and rubber, or the electronics are flowing along with the municipal solid waste, is an interesting question from my standpoint as someone interested in recycling. However, there's obviously other questions as well, like the life cycle impacts of these technologies. And these are the kinds of case studies that we plan to add into our model going forward. So I'll stop there at that point. I'm happy to answer questions, and I also, outside of today's call, have posted my contact information here if anyone is interested in discussing further or opportunities for collaboration in this area.
Thank you very much, Callie. We've gotten all kinds of great questions for you, so I'm going to direct a few right to you before we move on to questions for the group. Can you speak at all to whether or not you have an estimate of any errors that are any error that's inherent to your model? And have you found that error in the model improves with the availability of more recent data?
Yes, certainly. That's a great question, and especially for an academic like me, I spend a lot of time thinking about that. We have run the model many times, looking at many different scenarios, and what we have found is that the mega level trends fundamentally don't change in a significant way. You will see some change about, a certain product may grow faster or slower, or the mass contribution may be slightly greater or smaller. However, we are continuing to look at that, and so the ultimate goal is to publish something that shows maybe an upper and a lower bound of, or a best and worst case scenario. But I will say that probably the biggest uncertainty will be in the most recent years, so getting more recent data has been very beneficial. This is something we've been undertaking for a long time, using only publicly available data, and the addition of information from partners like CTA and others has greatly improved the accuracy of our modeling efforts. However, there is always going to be uncertainty. For example, some of these data are based on survey, and does a consumer really, when they're responding about the television they own, do they really know if they own an LED or an LCD? What is the uncertainty there? So there's some underlying uncertainty in the data. There's some uncertainty certainly in the material composition that we've found, although surprisingly less variability from product to product than we expected to see. When we looked at scenarios where you might go to, what if this class of products was all plastic or all aluminum versus a blend? But yeah, I don't know how else to answer other than to say yes, the uncertainty exists. But the fundamental question is whether or not that uncertainty prevents us from making a decision or changes our approach. And I don't think that it fundamentally changes our understanding or what we would then prioritize to do in the solution space.
Thanks, Callie. You were just speaking a bit about the sources of data that you've been using for this research. I know you've been using some sources that are peer-reviewed published data, some sources of industry data, and you've actually done some lab work in dismantling electronics as well. Can you speak to what portion of the data you're using comes from each of those sources, and if they're weighted differently at all in the model that you've developed?
Yes, that's a great question. Usually when we find a piece of data that that we're looking for, we're so happy to have any data at all. So it's rare that we would do any sort of like statistical treatment on the data because we just don't have a sample size large enough. We only have a few points. And there is no fundamental weighting aside from if we only have one source, that is the only source we use. In terms of the composition, I would say that the sales and ownership data are largely from our partners. That's not data that we have had calculated fundamentally ourselves, although we had previously done an effort to calculate some of these data and got pretty close to what these partners reports are saying. In terms of the mass and the material composition data, that's almost 100% either from our own efforts or publicly available peer-reviewed academic work or technical reports or other things that are available. And that's something we really view as an opportunity to contribute to this product, is making more of this information available to others so that it can be used for many different purposes, whether it be design or proactive planning for recycling or others.
Thanks. We've had a number of people asking about the use of flame retardants in plastics and electronics. I know that's not something that's part of the model right now, but is that something you anticipate adding to the model down the road? And either way, do you have a sense of the continued prevalence of the use of brominated flame retardants in plastics and electronics?
Yes, that's really interesting. One of the challenges we did face in going through this is our own, the challenges in disaggregating specific types of materials, whether it is a polymer or data from, some of our data sources provide the information as the specific type of plastic, some just say all plastic. So what we felt most comfortable presenting in this format was a cumulative total plastic. We do have some data that breaks down specific types, and from that we can look at literature values about concentration of flame retardants and do some disaggregated analysis. That hasn't been done yet, simply because there were some other materials that we were, I do a lot more work on metals, and so that's kind of where I naturally focused, but it's something that we hope to address in the future.
Thanks, Callie, and thanks again to you and to Mark and to Walter for some great presentations. We've got about 20 minutes left, and we'll leave a minute or two at the end to wrap up. But I'm just going to open up some of the questions that we've been getting throughout the presentations for the group. So one question, and I know this is near and dear to to the hearts of a lot of people on the line, is do you have a sense of how much of a part of the consumer electronics waste stream right now is precious metals? And what direction is this moving? If precious metals in electronics are on the decline, is there a sort of next class of commodities materials for electronics recycling? We can start at Callie and then move to Walter and Mark if either of you have anything to add.
Well, you started with me, but I was going to frantically dig up my Excel sheet where we actually tried to disaggregate gold, and so we do report some trends on gold. I mean, just looking at the mega level, material flows that I showed in the waste stream, the circuit board, for example, makes up about, I'm just going to eyeball it and say, 10% or 5% or less of that material stream. So certainly the precious metals contained in at least that product are small, and it is to some extent declining over time. I won't speak for Walter, who has a better can better represent the industry, but at least from what we've seen in academic research, is the growing areas of interest are in critical materials, rare earth elements. So we're thinking about neodymium, indium, tellurium, other materials that may be present in some of these products, as well as some of the battery materials, cobalt, manganese, zinc, graphite, and others. So to me, those are kind of some of the most interesting spaces to be looking at.
Yeah, this is Walter. Just to build on that a little bit, I think Callie nailed it. We are seeing over time a lot of the precious metals being engineered out, and we have seen that for the last couple of decades, particularly in most consumer electronics. I mean, based on my conversations with recyclers over the last few years, I don't hear a whole lot about precious metals as a target metal or a source of significant income on at least from consumer electronics.
Thanks. And this is another question for the group, but not to pick on you. I think I'll start with Callie again for this one. In the solutions phase of this research, are we focusing on reducing the entire footprint of products based on the materials analysis, or are you really focusing on end-of-life issues?
Yeah, so we haven't quite got to a solutions, in terms of this, because first, our first point is, it's kind of like when you go to the doctor, you first have to know what the symptoms are. We first want to really take the temperature and establish this baseline. And one of the things that we're hoping to do again in this next phase is we're planning to add some additional metrics here. So material footprint is just one metric, net mass. But certainly there's other things we're concerned about. For example, where are these materials coming from? So they're sourcing. How much energy does it take to extract and mine them, and to what extent can that energy be reduced by selecting recycled content versus others? Similarly, how recyclable are the materials and the products in which they're contained, and can we close the loop? Is there enough of a match between the outgoing waste stream and the incoming supply for a given year that we could theoretically close the loop in a circular economy? And similarly, what are the values of the materials in the waste? What are their potential impacts if they're released into the environment? So while we're not planning a full-out LCA, or life cycle assessment, we are planning to develop a suite of life cycle metrics and apply those so that we can understand, some materials might be a problem because of mass, others might be a problem because of embodied energy or price. And that should give us a little bit more of a holistic picture so that the solutions can target the hot spots in the system.
Yeah, and this is Walter. Just to add on that, I think this model and this approach can be helpful in identifying issues, both in terms of opportunities and potential areas of concern, and also as a way to put those issues into context. So, what is the scale of the issue, at least compared to the other materials being used in the products, and also be able to look at it over time. I think it'll be useful, at least at that macro level.
Mark, I don't know if there's anything you want to add to that answer.
Yeah, I mean, I think for us, we're really trying to use this as a predictive tool as well, and to think about what customers are going to be looking for in the future. But I would say that, as a private label brand, we're also very interested in material flows and where we might be able to utilize some of those materials in the future for some of our own products. So that would be the only addition I would make.
Thanks, Mark. And I'm actually going to start with you for our next question for the group, because I think you're well positioned to respond to this. We've gotten quite a few questions about the availability of e-waste markets in the U.S. And I know you work a lot. You work very closely with your recyclers. Do you or Walter or Callie have a sense of for materials without domestic markets right now, or for newer materials where the markets maybe haven't been developed yet? Are there incentives for creating them? And in general, is there a robust market for e-waste and for the materials derived from processing e-waste in the U.S.?
Well, from my perspective, I mean, I think obviously the commodity metals and so forth have a ready-made market, and both domestically and internationally. I think the bigger challenge is probably for some of the other materials like plastic resins and other materials that again, depending on whether we're talking about high-impact plastics or we're talking about other types of materials, there certainly are markets, but usually they tend to be low-grade markets. In fact, I think one of the things that is a big opportunity is really how do we develop these, the demand for robust and develop a robust secondary market for these materials, so that in fact we can create an onboard opportunity for these materials as part of design.
Yeah, and this is Walter. I would just add to that. I think for consumer electronics overall, recycling the picture's been dominated, at least recently, by CRTs. That's the technology and the leaded glass that comes along with that has proved, I think, challenging. I think there are some markets for that. you know, it's not a great market situation. It's definitely challenged. We've looked into it at CTA in prior years. We don't have anything recent in terms of looking at the markets, but there are some things that you can do with it. You know, it's expensive though, and I think we've got another challenge that's emerging on LCD panel recycling. I think we're going to see that for a while. I don't think it's going to be nearly the size or the scale of what we've got with CRTs, but that'll be a challenge. And I think, you know, as Mark said, I think we get down into then some of the other, you know, more. I mean, we got plastics, we got metals, some of the materials looking into the future, and I think we can see this by just looking at the composition of LED displays. They get to be a little bit more boring. Maybe they don't have the toxicity issues that the older legacy products do, but they also don't really have the precious metals. They don't have the things that are exciting economically either.
Thanks for that response, guys. Walter, I'm actually going to stick with you for a minute. In one of your earlier responses, you mentioned that the electronics industry has spent and not recovered about $125 million in dealing with meeting e-waste recycling requirements, and that you thought it was unlikely other industries would initiate that practice because of how the quote guinea pig of the electronics industry has kind of dealt with that. Do you see any other solutions? Is it the responsibility of an industry, electronics or otherwise, to be dealing with end-of-life management of the products they're producing? And if not, how do we avoid costs ultimately going to the consumers?
Oh, it's a great question. I think what we've learned through this process is that industry definitely has a role. I mean, we're not looking to change that in terms of our industry's participation in recycling our old products. I think where the real challenge for us has been on the financing and just how the financing has been applied to our industry. I think there are some good things that we've learned from some of the Canadian programs and how effective they've been, particularly on the financing side, but also on the operational side. I think there are a number of other models that that we're looking at that we can draw from. I think a lot of the existing manufacturer recycling programs have actually done quite amazing things in terms of getting a lot of material, a lot of products recycled in an efficient way. I think there's definitely value in that, and I would hope that would continue into the future. So I don't think it's not all bad news. We certainly have taken our lumps in terms of spending actually $125 million annually on this, but I think ultimately consumers need to understand that, particularly for products like these displays, recycling is not free. So you really do have to pay for it at one point or another. If not up front, then somebody's paying for it. And I think that's a message we could probably do a little bit better to communicate to consumers as well.
Thanks, Walter. We've gotten a few questions about plastics, and plastics are, of course, a material of concern not just in the electronics industry, but in a lot of other industries, especially from a recycling standpoint. And I guess I'll start with Callie, and then we can move to Walter and Mark, or if any of you have a response to this. Are you seeing any movement towards any sort of breakthroughs in plastics recycling, or towards there being more sustainable plastics being used in the electronics industry and elsewhere?
I'm probably not the best person to answer this because, again, I don't do a whole lot on plastics. But what I will say is, at least anecdotally, from our disassembly and other efforts, we have seen maybe not a switch towards different types of plastics so much as a switch away from plastics for many products. Now, that's not universally true, but most of the products, where we saw plastics being used before in terms of casings and others, you see fundamentally a smaller amount of that as time goes by. In both the larger products as well as in the smaller gadgets. So that's the only point that I would make, because I'm not an expert on the recycling of plastics, but we do see a shift, at least, again, this is consumer technology, fewer plastics versus light metals and others being used more commonly, which has kind of a different sustainability profile.
Yeah, this is Walter. To add on to that, I think we are seeing fewer plastics going in. We have legacy issues. I mean, one of the challenges with looking at the materials profile across time is we have existing challenges with recycling plastics, for example. But then looking forward, there are plastics going onto the market, and sometimes those are different issues. So with recycling, we have mixed plastics that create some challenges, at least for most domestic plastic recycling recyclers. But then we also have coming in some of the legacy flame retardants that were used 10 and 20 years ago that do show up in recycling streams now. Going forward, we're still going to have the mixed plastics problem in terms of being able to extract the high value plastics and that you can do with some of the post-industrial streams, but I think Mark's right. I think you mentioned that earlier, that I think there's some work to be done on the plastic side as well, even if we are using fewer plastics relative to some of the other materials in our products.
Thanks, Walter and Callie. Mark, we got a number of questions early on about Staples' circular economy and sustainability initiatives. Can you speak to how Staples is able to pursue this work without incurring a competitive disadvantage, or even if Staples, in your opinion, is able to pursue this work without incurring a disadvantage?
Yeah, I mean, I think initially, we're very fortunate in that we have, we have access to some material streams that are essentially closed loop. So, for example, ink and toner cartridges, our ability to recover those cores and then put them back into service, through our remanufacturing partner, and then ultimately get those materials back at end of life when the cartridge can no longer be remanufactured, allows us to take that, those resins and put them into other materials. So where it's easy and as a drop-in, it certainly makes a lot of sense. We also have a partner in Davies Office, which is a furniture remanufacturing company that takes, and as I said before, reindexes high cubicle systems, manufactures low cubicle systems, basically puts new paints and finishes and removes fabrics and meets a level BIFMA standard, within the furniture industry for for sustainability. So and we're doing all of this, by the way, for those products in particular at a lower cost, right? So it doesn't always have to cost more. So what we're trying to do is continue to uncover those opportunities to create and uncover more value within the product flows that we control directly, and then the ones that we don't, find partners hopefully that will be able to provide either feedstock or at a competitive price. So at the end of the day, our consumers really care about, does the product meet fit, form, and function? Does it cost the same, or in some cases a little bit less? And oh, by the way, can it be better for the environment? And I think if we can, check the boxes off on all of those criteria, then at the end of the day, we're continuing to move the effort forward. But to answer your question, I mean, it's obviously the reason that we partner with the Rochester Institute of Technology and the Golisano Institute, and obviously do good work with organizations like CTA that are really looking at, okay, here's where we are today from a baseline perspective. What is the new normal going to look like, 10 and 15 and 20 years down the road? And candidly, we don't know what it is, but, very excited to be part of this kind of research to start to at least establish a baseline of where we are today and hopefully become more predictive in terms of where these material flows start to move in the future and where we can take advantage of those opportunities.
Thanks, Mark. We definitely only have time left for one question, but I'm going to try and get at a fairly high-level question that was asked, and I'm going to start with you, Walter, and then move to Callie and Mark if either of you have anything to add. But it sounds like some of the material value is being engineered out of electronics as the use of precious metals decreases and other materials are taking their place. Are there ways that you think the value of electronics for reuse, either entirely as a whole product or for parts, is being increased to make up for that?
Oh, sure. Yeah, I think actually that is how a lot of recyclers keep going. That's certainly the reuse and refurbishment markets. Reuse not only of devices but of components is a big part of where recyclers find value. And I think going forward, it's where our industry it changes rapidly and these products change. Recyclers have a little bit of an advantage because you can see a little bit in the future what's going to be showing up on your dock 3 and 5 and 10 years from now. So I have every confidence that recyclers will continue to find ways to find value and get value out of these products going forward. Even as we've moved from an industry that's looking for precious metals to base materials to looking component reuse. It goes through phases, and I think the ingenuity of the American recycler will continue to figure this out going forward, I'm sure, and hopefully this type of analysis can help a little bit in framing the issues and providing the data.
Callie and Mark, do either of you have anything you want to add in the last 30 seconds?
This is Mark. I mean, I guess just to add on, I think to what Walter said. I think that there are new business models that are outside the realm of just recycling. Obviously, remanufacturing is a huge component in many industries like the automotive industry and so forth, and I think certainly is robust in electronics. And I think it's a matter of, can we kind of cross-pollinate some of these material flows where it makes sense and where it's safe to do so, so that we can create the highest economic value for the system at the lowest environmental and social burden on the overall system. I think that's essentially what circular economy is all about.
Well, once again,
Brandon, sorry, I was just going to quickly say, I mean, I think that while I'm not sure I don't necessarily know the answer to the question yet about some of these future opportunities, I think it underscores the need for a really data-driven approach. And I'll just conclude by saying that, we're expanding this ecological model a little further. For example, we currently have some research where we're looking at ecological foraging models, or else how animals choose to eat, and trying to apply those to recycling cases. So I think there's a lot of unexplored territory, and to develop these kind of models and data-driven methods, and hopefully we'll be able to inform us some of those going forward.
Thanks, Callie. So we've come right up to the end of our hour and a half. Once again, I'd like to thank all three of our speakers, Mark Buckley from Staples, Walter Alcorn from the Consumer Technology Association, and Callie Babbitt from the Rochester Institute of Technology for talking to us today about this work on the materials footprint of consumer electronics. I, for one, am very excited to follow this work moving forward over the next year and beyond, as I'm sure many of you are as well. Finally, most of all, thanks to everyone on the line for joining this month's SMM Web Academy, and for a large number of you staying through all the way to the end. We hope you will continue to join us for future webinars. It's all of you that this program is designed for. Please make sure, if you have the time, to complete our evaluation and to give feedback on how we can better meet your needs in future webinars. The webinar audio will be posted in about 2 weeks, and all of the slides from the 3 presenters today should be up on the SMM Web Academy website next week. Please join us for next month's webinar, which will be on May 25th at 1 p.m. Eastern, where we'll be talking about the public action stars of recycling. You can look for more information about this webinar in the coming week. So that concludes today's session. Thank you all.